Alright, so here we're going to have another look at a 2014 University Calc 1 exam question. This is question 13 from this particular paper. So this is the area of a triangle with vertices 0, 0, 0, 1, 2, 1 and minus 5, 0, 5. So this is going to rely on a very particular use of mathematical methods you encounter in this course. It's actually going to rely on cross product. Really, this is the main thing that's happening here. If you have two vectors, let's call them vector u and vector v. We could put a little wiggle over the top of them or a line over the top of them. We're just going to assume you understand that u and v are vectors u and v. The norm, the length of the cross product vector between u and v is actually equal to the area formed by turning these into a parallelogram. So this area contained in here is actually equal to the norm of the cross product of the vectors. So if we want to find the area of a triangle, we can just take 1/2 times the norm of the cross product of two of the vectors making up the sides, assuming that those two vectors start at the same point, and this will give us the area. So we know that the area of a triangle is equal to 1/2 times the norm of u times v, so u cross product with v, where u and v are two sides of the triangle. So here we have some arbitrary triangle. We'll draw a little picture. It's not going to be perfectly to scale, but it's going to be fine. This is P, 0, 0, 0. This is Q, 1, 2, 1. And this is R, minus 5, 0, minus 5. So we need to find two of these vectors in order to do the cross product. So two obvious vectors are this vector and this vector. The reason these are obvious vectors is the vector from P to Q, which we'll call PQ, and the vector from P to R, which we'll call PR, are the same as Q and R. PQ is Q and PR is R because P is the origin. So we don't have to do any vector addition or subtraction in order to find PQ and PR. If the P was not at the origin, then you would. You have to do subtractions to find the vectors connecting the two, but here it's the origin. So we know PQ is the vector 1, 2, 1. We know PR is the vector minus 5, 0, minus 5. And so now the area of a triangle is going to be 1/2 times the norm of the cross product of these two vectors. So now we need to do the cross product. So we'll use the Saris rule, ijk, first vector, 1, 2, 1. Do it again, ijk, first vector, 1, 2, 1. Second vector, minus 5, 0, minus 5. Minus 5, 0, minus 5. Now the Saris rule, we're going to be multiplying the numbers together in these three diagonals, then adding them together. So PQ cross with PR is equal to I times 2 times minus 5, which is minus 10I, plus J times 1 times minus 5, minus 5j, plus k times 1 times 0, which is plus 0k. And then we're going to be subtracting these three diagonals. So we've got minus k times 2 times 5, that's plus 10k. We have I times 1 times 0, that's minus 0i, plus 0i, doesn't really matter. J times 1 times minus 5, that's plus 5j. Now, when we put this all together, we have minus 10i plus 0i, so that's minus 10i. We have minus 5j plus 5j, that's plus 0j. And we have 0k plus 10k, that's plus 10k. Now if we write this in a more normal vector form, minus 10, 0, 10. So now we need to find the norm of this vector. This is just the square root of the sum of squares of its components. So the norm, PQ cross PR, this is just the length of the vector really, is equal to the square root of the sum of squares. So this is minus 10 squared plus 0 squared plus 10 squared. Norm is actually not necessarily a hugely common terminology. It's not a terminology you have to use. Okay, you can use it, but length, so long as you're correctly describing, I'm finding the length of the cross product vector, that is the same as the area of the parallelogram formed by the two vectors. So this is equal to the square root of 200. This becomes, let's see, we have square root of 4 times square root of 25 times square root of 2. Because 25 times 2 is 50, 4 times 50 is 200. Square root of 4 is 2, square root of 5 is, the square root of 25 is 5. 2 times 5 is 10, so this is 10 root 2. Now the area of a triangle is 1/2 times this value, 10 root 2. This is 5 root 2. And this is in fact answer D. So this is one way that you can find the area of triangles where the triangle sides can be thought of in terms of vectors.